Assalamualaikum warahmatullahi wabarakatuh. Okay, today lecture is about chapter number 5, part number 2. Chapter number 5, part number 2. In terms of subtopic, we will discuss about the monitor and also improvement process, introduction to the energy performance indicator and also energy baseline, develop, use and update the energy performance indicator and also energy baseline, energy, the specific subtopic for energy performance indicator, which is also referred to ENPI, and also the energy baseline, which is referred to the ENB. And the last one, we'll discuss about the planning for the collection of energy data. About the monitor and also improve process. So last time in the previous chapters, we already learned about the processes involved for the plan. So we have first step under the plan, what I call procedure. So we have planning output, and then we have planning, and we need to conduct the energy review under the planning section. And the last one, we will have planning outputs. So under the planning output, we'll have numbers of outcome, such as objective, target, action plan, risk informed, and also the indicator of the energy performance. And especially for the action plan, so we need to monitor the action plan, whether the action plan can be implemented or the action plan can be successfully implemented or not. So we need to monitor what we call the progress of the action plan by referring to the energy performance indicator and also the energy baseline that we decide after we conduct the energy review. So the monitoring process actually refer to the track progress that we will use to in this process we will use energy performance indicator to monitor the improvement over the time. And this process monitoring allow the organization to assess whether the energy management plan is on track and achieving its intended outcome. So these are the process that we want to make sure that the implementation of the action plan. After the monitoring process, we will have improvement process, where this improvement process also we need to refer to the indicator, energy performance indicator and also energy baseline parameter, because we will use this parameter to as a what I call as a guide whether our target or our objective achieved or not. And then we need to revise based on the what I call on the outcome or the result that obtained from the monitoring process. We need to improve or we need to revive the energy review process and so on. So under monitoring process or monitor process, there are few parameters. So what we need to monitor during the process, first is about the significant energy use or SEU. So we need to regularly track the consumption and also the energy performance, energy consumption and also energy performance. We also need to monitor the energy performance indicators that we use. So we need to monitor KPI, key performance indicators that measure energy efficiency. We need to monitor the improvement action, where we need to track the progress of planned actions. We need to monitor also the cost saving, where we need to evaluate the financial saving during the process. Okay, what kind of data source? So we can get the what I call the data from the energy meter and also submeter. We also can get the data from the utility bills, operational record and logs, and also from the real-time monitoring system. In terms of frequency, how frequent we need to monitor. So we need to define the interval for monitoring based on the nature of the data and processes. So there are few types of what I call frequency of the monitoring process. First, we have real-time monitoring for equipment using sensor and also EMS tools, energy management system tools. Or we can monthly review of utility bills and also energy consumption trend. Or we can what I call quarterly evaluate of action plan and also energy performance indicator. So these are three options that we can implement in terms of frequency of the monitoring process: real time, monthly, or quarterly. And we need to evaluate the effectiveness. We need to compare against targets. We need to track the objective, where we need to compare current energy consumption and also energy performance indicator against set target and also baseline. We need to evaluate deviation, where we need to identify any gaps between actual performance and also the expected outcome. So in order to evaluate effectiveness, we also need to analyze the result, where we need to evaluate deviation, use data analysis techniques to understand trend and also pattern in energy use. For example, a sudden spike in energy consumption in terms of graph and so on may indicate operational inefficiencies, equipment failure, or changes in production schedules. Okay. Also, we need to have verification of improvement. Measurement and also verification protocol are used to confirm that energy saving are achieved. For example, operator may provide insight into practical challenges or suggest improvement. Okay, next. Okay, just now we already explained a little bit about the monitoring process or monitor step. So now I will explain about the improvement process or improve step in this course slide. So where for the improvement, we need to adjust the plan. We need to adjust the plans. We need to revise action plan and also prioritize based on the latest energy review. So under the improvement process, we need to have continuous improvement. We need to conduct periodic review, schedule management review to evaluate the overall performance of the energy management system. We need to review energy policy, review the objective and also target to ensure align with the organizational goals. We need to update documentation, where we need to reflect any changes or update in the energy review report, action plan, or other energy management system documentation. Okay, so in order to have continuous improvement, also we need to have training and also awareness. We need to have continuously trained staff to ensure they know new policies, processes, and energy saving practice. Benchmarking, we need to compare the organization performance with industry peers or standard to identify new improvement opportunities. So in terms of benchmarking, we also need to compare with other organizations in terms of our energy performance. So in order to make improvement also, we need to identify area of improvement, such as we need to reassess the SEU, we call significant energy use. So we need to identify the new area of improvement. So we need to ask, are there new or previously unnoticed area consuming significant energy? And also we need to ask, are current SEUs performing as expected? Also, we need to revise action plan, update or replace ineffective action with more impactful ones. For example, if optimizing HVAC setting didn't reduce energy use as expected, so we need to consider upgrading the system or improving installation. Also, we need to have incorporate feedback. We need to engage staff and stakeholder to gather feedback on implemented action and also processes. For example, operators may provide insight into practical challenges or suggest improvement. Okay, so these are the explanation about the monitor and also improvement steps. Okay, example in terms of monitor and improve. For example, for the monitoring, so the table shows the what I call the example for the monitoring process. So we have parameter, frequency, responsibility, and also tool or method. For example, in terms of energy consumption, in terms of frequency, how many times we need to monitor the energy consumption. So for this case, for this example, the what I call the frequency will be monthly. We need to check what I call the energy consumption month by month. So for every month, we need to check the energy consumption. Who is responsible to make sure this process occur is the energy manager. And the tool that we use for to monitor the energy consumption is by checking the utility bills and also the energy meters. Okay, energy meters. Another example is about the parameter involved in terms of HVAC system performance. So we need to check in real time. Responsibility conduct by the facility maintenance teams, and the tool will be EMS software or on-site sensor. Action plan implementation frequency quarterly. Responsibility will be conducted by the project team lead. So the tools, you need to check the progress report and also audit report. In terms of financial saving, how much money can be saved by reducing the energy consumption. So we need to check quarterly. Responsibility by the finance department, and the tools that we need to use is cost analysis of energy saving. So the example for the improvement, so we have issue identified, action taken, outcome. So for example, the first issues, we have higher energy consumption in SEU1, number 1. Action taken, we need to conduct maintenance and also fix leaks, whatever leak happen in the processes, in the line. So the outcome, by implement the action, we can reduce energy use by 80%. Sorry, by 8%. So we can reduce energy use by 8%. Second issues, ineffective lighting replacement. So action taken, upgrade remaining fixtures to LED. So achieve 15% overall energy saving. And the third issues identified, HVAC system operating inefficiently. So action taken, install VCD on motors. And in terms of outcome, you can improve efficiency by 10%. So these are the example of the table for the monitoring and also the improvement. Okay, now about the introduction to energy performance indicator, or we call the short form for the energy performance indicator, ENPI, and also energy baseline, ENBS. Okay, so energy performance indicator, ENPI, and also energy baseline, ENBS, actually are the key interrelated element of ISO 50001. So the ISO will use this parameter to check the performance of the energy consumption under the ISO 50001. Okay, so this parameter enable measuring and also managing an organization's energy performance. So energy performance actually a broad concept based on target, which is include the energy consumption, which is referred to the quantity of energy applied, energy use, manner or kind of application of energy efficiency, which is referred to the ratio between a performance output and also an energy input. So the energy performance affected by relevant variables, which is referred to the quantifiable factor that routinely change. For example, production output, operating hours, occupancy level, ambient temperature, and also the energy price. So these are variables that routinely change over the time. And also affected by the static factor. Static factor refer to the identified factor that not routinely change, such as the building size and location, installed equipment, type of operation, and also the shift pattern. So the organization responsibility in terms of energy performance. So the organization need to define target for the energy performance as part of the energy planning process in their energy management system. The organization need to consider the specific energy performance target while identifying and also designing the energy performance indicators and also energy baseline. So energy performance indicator, ENPI, actually refer to the quantitative value used to measure and track energy performance over time. So the purpose of ENPI is to monitor energy efficiency or performance trend, and also to support decision making for the energy management. However, for the energy baseline, ENBS, refer to the quantitative references, providing a basis for the comparison of energy performance. So the purpose of ENBS is to establish a benchmark for comparing energy use and helps measure the impact of energy saving project. Okay, so these are the general what I call the information about the energy performance and also the parameter or the measure that used to measure the energy performance, which is referred to the ENPI and also ENBS. Okay, now about the still under ENPI and also ENBS. So what is the relationship between energy performance, ENPI, ENB, and also energy targets? So energy performance consists of energy consumption, energy use, and also energy efficiency. Okay. So all these what I call criteria of energy performance will be measured by using ENPI. So ENPI stands for Energy Performance Indicator. Okay. So we have reference ENPI value in baseline period. So baseline period refer to defined period of time used to compare energy performance with the reporting periods. So reference ENPI value actually also refer to ENB, which is energy baseline. So energy baseline in terms of definition is quantitative reference providing a basics for comparison of energy performance. So each individual organization will have target, which is referred to the energy target, a value that the organization want to achieve in terms of energy consumption. So any energy consumption must less than this target, so that in order to achieve the target, the value of certain organization in terms of ENPI must be less than the target value. So let's say for the first case, the current ENPI value within the reporting periods is under the target value. So where the reporting period refer to the defined period of time selected for calculation and also reporting of energy performance. So this is what we call the period where we need to evaluate the actual energy consumption. The first case where we have the value of ENPI lower than the target. So we can say that for this ENPI value, so that particular organization will have improvement in terms of energy consumption, where ENPI improve, where the value of ENPI lower than the target. So we consider the target of the specific organization target was achieved. The second case, where the ENP value is greater than the target, and it's, the value of ENPI is greater than energy target, but still lower than the energy baseline. So we can say that the conclusion for this case, we don't have any improvement. ENPI not improved, where the ENPI higher than the targets, so the target was not achieved. The last one, the last case, where the current ENPI value in the reporting period higher than energy baseline. So we will have worsen case where the value of ENPI worsen higher than the baseline value. So the target also not achieved. So in order to understand about the process of evaluating the energy performance indicator, and also the what I call the meaning of the energy baseline, we need to see this graph, where we have this graph where we have energy consumption versus time. So within in the graph we have in terms of period of time, the blue color date represent the first year, the green color date represent the second year, in year 2022 and also 2023. So the baseline period normally refer to the previous years. For this case, we refer to 2022 as the baseline period. So in this period, we will have the data for the energy consumption at that particular years. And the graph refer to the measured ENPI, energy performance indicator, in baseline period. Also, the data known as ENB, which is energy baseline. The second period will have reporting period, where the actual period that we use to measure what I call the energy consumption compare with the baseline period in order to improve the energy consumption. Let's say we have the green color line in terms of energy consumption, where we can see that the reduction of energy consumption. So the green line graph represent the measured ENPI in reporting period, which is referred to the current ENPI. Also in the graph shows the adjusted energy baseline. So this adjusted energy baseline actually refer to the measured ENPI in year 2022, where the line also refer as the energy baseline. So the adjustment refer to the process of modifying the energy baseline in order to enable energy performance comparison under equivalent condition between the reporting periods and also the baseline period. Okay, the orange area represent the saving. How much saving occur after we implement certain certain improvement in order to reduce the energy consumption for the year 2023. And in between baseline period and also reporting period, we have the installation period, where we install the energy efficient system, where energy efficient system installed during that period. So during that period, we don't have any evaluation about the energy consumption. So we just refer to the reporting period after the installation period. Okay, develop, use and update the energy performance indicator and also energy baseline. So these are the processes for the develop, use and update the ENPI and also ENB, energy performance indicator and also energy baseline. So first, we have the purpose of the energy review. Second, process involved is defining the ENP boundaries. Third step, quantifying energy flows. Set number 4, defining and quantifying relevance variables. Set number 5, identifying static factors. And the last one, data collection and quality assurance. So we'll discuss one by one in terms of step of develop, use and update the ENPI and also ENB. Purpose of the energy review. So the purpose of energy review to provide essential information in terms of identifying energy performance indicator ENPI, establishing energy baseline ENBS, and also assessing the energy performance over time. So these are the purpose of the energy review. And also the purpose of the energy review, gathering and also analyzing energy related data to make informed decision about energy management and also improvement action. For example, we have a scenario where a manufacturing plant use electricity, steam and compressed air for production. Energy costs have been rising. So in terms of energy review process, we already learned about the energy review process in previous part. So we need to analyze energy use. So for this case, the energy use refer to the electricity power motor, HVAC system, steam, and also the steam for sterilization. So we need to identify the significant energy use. So for this case, we already identified the boiler system and also the HVAC system as our SEU, around 60% of the total energy consumption consumed by this system. So we need to access the variables. So for this case, the access variable refer to the production hours, ambient temperature, and also the steam pressure, which is considered as the significant factor for the manufacturing in terms of energy consumption. And we need to identify the improvement opportunities. So in order to reduce the energy consumption for this manufacturing plant, we need to optimize the boiler efficiency with regular maintenance. And also we need to install energy efficient for the HVAC system. Okay, the other improvement that can be implemented, we need to introduce an operator training program for energy saving practice. So the outcome of these I call processes. So the review identifies opportunities to reduce energy costs by 50% through targeted improvement. So these are what I call the example of the energy review under develop, use, update the ENPI and also ENB. Okay, still under purpose of the energy review. So for example, also for the energy review, we have milestone. So these are example of the milestone for the energy review. Okay, we have task versus timeline. So we have numbers of activities involved for the energy review, such as form an energy review team and assign responsibility, gather existing document, collect historical energy consumption data, install sub-meter or monitor system, and the last one, maintaining documentation. So these are example of the energy review milestone. Okay, for example, so now this example is about the energy review activities. If you look at the table, we have numbers of activities involved with energy review. First, we have analyze energy use efficiency and consumption based on measurement and also the data. Number 2, based on the analysis of energy use efficiency and consumption data. So we can identify the area of SEU. And the third one, identify, prioritize, and record opportunities for improvement in energy performance. So these are the main activities for the energy review. So under each main activities, we can divide into few others activities, such as under analyze activities, we have identify current energy sources, evaluate past and present energy use, and also consumption, where for the specific activities, we need to create a list of energy source and also energy values, create energy value strength chart based on the use in terms of purpose, create energy value strength chart by referring to the source of energy, and under what I call identify the area of SEU, which is referred to the second activities of energy review. So we have identified the facilities, equipment, system, process, and so on. We need to identify other relevant variables affecting SEUS. We need to determine the current energy performance of facility, equipment, and also the processor related to identify SEU. And also we need to estimate the future energy use and also the consumption. So each individual what I call sub activities for the energy review, we have very specific typical activities as shown in the table. Okay. Okay, so you can read I call the detail of the activities in the table as your reference. Okay, now about the defining energy performance defining the energy performance indicator boundaries. Okay, energy performance indicator boundaries, where we need to specify the physical, organizational, or system limit for measuring energy performance. So these boundaries ensure that data collection and analysis are relevant and focused. So the purpose of this step to ensure that the ENPI reflect the specific energy use and processes under the organization's control. To enable consistent and meaningful comparison of energy performance over time, to focus monitoring effort on areas of significant energy consumption or improvement potential. Consideration of the boundary, scope of operation. So we need to identify the specific processes, system, or activities to include within the boundary. The organizational responsibility. The organization need to ensure that the boundary include only those activities, facilities, or system under the organization operational control. Ease of measurement. We need to ensure that the data required to monitor the boundaries energy performance is accessible and also measurable. SEU, significant energy use. We need to focus ENPI's boundary on SEUS to prioritize high impact area for the energy management. Influencing variable, we need to consider external and internal variable impacting energy performance within the defined boundary. Consistency over time. So the defined boundary in a way that, so we need to define the boundary in a way that allow for consistent tracking and also comparison of energy performance indicator value over time. So these are the consideration in order to define the boundary for the energy performance indicator. Okay, so this diagram shows the energy performance indicator boundaries division processes. So the first step, we need to decide what I call the boundary for the entire boundary that involved in the system. And also we need to have the energy management system boundary. So you need to make sure we need to identify which part or which boundary will implement the energy management system. The second step, we need to identify the boundary for the SEU facilities. Okay, so we have ENPI boundary for the SEU facilities, and the rest we consider as a ENPI boundary for the other facilities that not considered as SEU. And the third step, we need to set the boundary for the SEU equipments. So we will have an ENPI boundary for the SEU equipment, and the rest we consider as ENPI boundary for the other equipments. Okay, still under defining the ENPI boundaries. For example, I will try to illustrate or try to show you more realistic in terms of how to implement the ENPI boundaries division processes. So, for example, we have a specific plan layout plan for the Hupo factory. First step, we need to identify the entire boundary that we need to implement the energy management system. So for this case, we consider the whole Hupo factory. And then we need to identify the facilities involved, all the facilities involved in the entire boundary. The second step, we need to identify the facilities that consider as SEU, significant energy use for specific facilities. For this case, facilities number 2, number 3, and also number 4 consider as SEU, the facilities that consume more of energy consumption compared to the other facilities. Okay, so we have ENPI boundaries, which is referred to the SEU facilities, and the other facilities we consider the other facilities not include in SEU, we consider as ENPI boundary for the others facility. Okay, and then for the step number 3, we need to identify the equipment involved. For example, for this case, equipment involved, equipment number 1 until equipment number 6 in that factory, and we need to determine which equipment considered as SEU that use more energy within the boundary. So we have boundary for the SEU equipment and also the ENPI boundary for the other equipment that not considered as the SEU equipment. So these are how we divide the boundaries for different categories in terms of energy consumption for the specific factory. Okay, for example, in the table shows the what I call the energy performance indicator, the boundary, and also the exclusion. Exclusion means we exclude certain what I call facility, certain system or certain equipment in our energy management system. Okay, for example number 1, the facility level boundary. So in terms of ENPI, we have total energy use per square meter, kilowatt hours per meter square. The boundary will be entire office building, including lighting, HVAC, and also equipment. So exclusion shares utility outside the organization control, for example, the central heating. So this part will not include in our assessment. Example number 2, system level boundary. ENPI, energy consumption per ton of steam, kilowatt hour per ton. Boundary, boiler system, including fuel usage and also steam generation equipment. Exclusion, heat distribution system beyond the boiler rooms. And the last one, equipment level boundary. ENPI, energy consumption per operating hours, kilowatt hours per hour. Boundary, a specific CNC machine in a manufacturing plant, where for this case, we focus on the CNC machine. And the exclusion, supporting equipment like compressor or lighting. So the compressor and also lighting for the equipment level will not involve in our assessment. So these are the example of the defining the ENPI boundaries. Okay, now about the quantifying energy flow. So quantifying energy flow refer to the process will involve measuring the energy entering a system, which is input, how it is distributed and utilized, which is referred to the flow, and the output is produced. So this process provide the foundation for identifying inefficiencies, establishing a baseline, and also tracking improvement in energy performance. So energy flow, once energy performance indicator boundaries are defined, energy flow across those boundary must be identified and measured. This include energy input, such as energy source, for example, electricity, gas, and also steam. Energy output, product or service generated using the energies. Metering point, location where energy is measured. Step for the quantifying energy flow. So energy flow analysis step involve with first energy input. We need to identifying and also measuring energy source entering the system. Step number 2, energy flow. We need to mapping the pathway energy takes within the system. Step number 3, energy consumption, quantifying energy usage at various system point. Energy output, measuring the result of energy use, both useful and also wasted. Number 5, losses and also inefficiency. We need to analyze area of energy waste and also under utilization. And the last one, the total energy balance, where we need to evaluate the overall efficiency of energy use. So these are the steps for the quantifying energy flow. Okay, now the visualization tool that used to shows the energy flow, we call Venn diagram or energy maps. So this tool will consider as visual representation, which showing the energy flow, metering point, and product flow within the energy performance indicator boundaries. For example, this is what I call the example of the Venn diagram or energy maps. So we have numbers of building involved. So the schematic diagram which shows the numbers of building, the equipment that use, the process involved, and also the what I call the department involved in the boundary. So the M symbol represent the measurement point in order to measure the energy use and so on. So these are the example of the Venn diagram. Okay, now we continue with defining and quantifying relevance variables. Okay, defining and also the quantifying relevant variables, which is referred to the factors that significantly influence energy performance within an organization. So we have relevant independence variable, such as operational variables, factors tied to the production or process activities, environmental variables, which is referred to the external condition that impact energy use, behavioral variables, which is referred to the human action influencing the energy consumption. So these are the variable that considered as relevant independent variables. Next, we have in terms of process, analyze the variable impact. We can use the trend analysis, which is referred to the time independence analysis. So the time independent analysis we already discussed. What I call the topics. We already discussed in part number 1, chapter number 5, part number 1. So time-dependent analysis has limitation. It is difficult to identify why certain trends occur. And the other option in terms of analysis, we can use correlation analysis such as regression analysis, where for this analysis, the analysis will remove the time element from the analysis, which is referred to the statistical technique, determines and quantify the relationship between variables. And also we have a certain type of graph that we call cumulative summation or CUSUM, which is a measure of the progressive deviation from a standard consumption pattern. These are the analyses that can be used for the energy consumption analysis. And the challenges in terms of defining and also the quantifying relevant variables are the data availability, lack of metering or monitoring system for these specific variables, complex relationships where variables may interact in complex ways, making analysis difficult, the accuracy of the data, where inaccurate or incomplete data can lead to poor decision making. So these are the challenges in terms of relevant variables, in terms of defining and also quantifying relevant variables. Okay, still under analyze variable impact. So we will use correlation analysis, which is referred to the regression analysis. So the regression analysis actually is the management tools enable standard equation to be established for energy consumption. So we can, for the regression analysis, the focus is the variable which influence the energy consumption. And the regression analysis is very much dependent on the quality of the data used. So the significance of the result depend on the quantity and quality of the data used and also the variable used. Okay, so this example of the what I call the possible factors. For example, the commodity, electricity, duty performed outside security lighting, and the possible factor hours of darkness. Water, swimming pool makeup, numbers of bath. Gas, space heating, possible factor heating degrees days. Oil, commodity in terms of oil, duty performed, steam rising in boiler plant, and possible factor amount of steam generated, and so on. So these are examples of the possible factor for different type of energy source of commodity. Okay, under regression analysis, we have linear regression analysis. So the relationship will be linear. So the analysis will derive using equation for the best fit straight line curve through the point plotted. The best fit straight line curve is determined by summing the square of the distance from the straight line of the various data points. So later on, we will explain about this, the explanation for the linear regression analysis by using this specific graph. And the linear regression analysis can be used to predict future energy consumption and also can be used as a standard performance equation for energy monitoring and also targeting purpose. Okay, in order to explain the concept of linear regression, we need to look at this graph. So this graph shows the energy consumption versus the variables. So data, we will have data point number 1 until point number n that consists of X data and also Y data. N represent the number of data. So X1, Y1 refer to data number 1. X stand for the variable value. Y stand for the energy consumption value. So we have second data, data number 11, data number 12, and N data. So N represent numbers of data. So by using the linear regression, we'll have the linear relationship for all the data plotted on the graph, and the equation, the linear equation that we obtain from the linear regression will be y equal to mx plus c. M represent the gradient of the line, and c represent the intersection of the line with the energy consumption axis. Okay, so in order to what I call to obtain the m value and also c value for the equation, we need to provide equation number 1 based on the data, what we call data point on the graph, where we have equation number 1 c, which is referred to the c in the equation, multiplied by n numbers of data. For this case, we have 12 data, for example, or 13 data, but plus m, which is referred to the m in the linear equation, summation of x data. So we need to summing all the data for x value equal to summation of all data for y value. So we will have equation number 1. Equation number 2 involves with c value in the graph, sorry, in the equation, multiplied by summation of x data. plus m multiplied by summation of square x data equal to summation of x data multiplied with y data. So we will have equation number 2. So we need to solve these two equations in order to obtain the value of m and also the value of c. So when we calculate the value of m and also c, we will get the what called the complete linear equation that describe the behavior of that point, data point on the graph. So we can use this equation to estimate the energy consumption for the future energy usage. Okay, so now the example for the linear regression analysis. So for example, we have the table. So we have the data for 2023, start from January until December. So the data for one years. So Y data refer to the electricity energy that used, and X data refer to the production in terms of kilogram. So we need to calculate for each month the value of X square, and also the value of the multiplication of X and also Y value. So we need to provide two separate columns in order to get the data for X square and also XY. And we need to make summation for all data for Y, all data for X, all data for X square, and all data for the XY as shown in the table. Okay, so from all this data, sigma Y we refer to the summation of Y, sigma X summation of X data, sigma X square refer to the summation of X square data, sigma XY refer to the summation of XY data. So we'll use all this data, substitute into the equation number 1 and also equation number 2. Okay, so numbers of data refer to the table. We have 12 data, represent 12 numbers of data, refer to the January data until December data. So equation 1, Cn plus m sigma x equal to sigma y. So we already calculate sigma x and also sigma y. Substitute in the equation. Same goes to equation number 2. Substitute sigma x squared, and also sigma xy into the equation number 2. From equation number 1, we'll get equation 1a, 12c plus 4234m equal to 2494. Equation 2, from equation 2, after we substitute the value, so we'll get EQ2A 4234C plus 1577254M equal to 884419. So we need to solve the equation. So we will get M equal to 0.053, C equal to 188.986. So if you substitute the M value and the C value into the general linear equation, Y equal to mx plus C, we will get y equal to 0.053x plus 188.986. So this is a relationship for the data in the tables by using the linear regression analysis. Okay, still under analyze variable impact. For the linear regression analysis, we have what we call correlation coefficient, which is represented by R symbol. So this R symbol used to determine how well the best fit correlate to the sample data. So in order to determine the value of R, we need to calculate the Pearson correlation coefficient, also referred to the R value. Shows an indication of the reliability of the line drawn in the graph. The Pearson correlation coefficient, which is referred to the R value. So R value will be in between 1 and 0. Is a value of 1 represent 100% correlation, which is good. So the value of R can be calculated by using this equation. sigma x minus x bar, y minus y bar. So x bar refer to the average value of x data, y bar refer to the average value of y data. Divide by square root of sigma x minus x bar squared multiplied by sigma y minus y bar squared. Okay, so x bar equal to x data average, y bar refer to y data average. So Pearson correlation coefficient R, in terms of definition, is the measure will be the coefficient will measure the strength and also the direction of the linear relationship between two variables. In terms of interpretation, so the R value indicate whether the relationship is positive or negative and how strong its linear relationship is. So the purpose of the Pearson correlation coefficient is to describe the relationship strength and also direction between two variables. However, for the R squared, in terms of definition, represent the proportion of the variance in the independent variable that is explained by the independent variables in a regression model. In terms of interpretation, so R square value quantifies how well the regression model fit the data, the goodness of fit. The purpose to measure the model ability to explain variation in the dependent variable. Okay, so for example, so the example of the graph shows the significant variable where we have high value of Pearson correlation coefficient R, which is now referred to 0.9636. R squared value also good, which is equal to 0.9285, which is close to 1.0. Example number 2, less significant variable. So we will get less value of R, so R square, 0.8 and also 0.7 respectively. And the worst case, not significant variable, R equal to 0.49, R square equal to 0.24. So we can look in terms of feature, the different features in terms of data and also the line provided for the linear regression. So, okay. So the best significant variable condition are shown by the first graph, where we will have all the data will located very close to the linear line that formed by using the linear regression analysis. Okay, so if we have a lower value of R or R square, we can see that the data of the energy consumption will spread out from the linear line. Okay, so the best one is the first graph that show higher value of R and also higher value of R square. Okay, now the example of the correlation coefficient R. Okay, now I will show you the example for the how to determine the R correlation. So we want to know how good the data that we obtained from the previous example. So we'll use the same data in terms of energy consumption. And the equation that we use to determine R is the equation for the Pearson correlation, as shown in the slide. And the linear equation that we use for this analysis refer to the equation that we obtained from the previous example, and we will use the same data. So we'll get the linear relationship in terms of what I call relationship for the data, y equals 0.0563x plus 188.986. So the green column, which is represent the data for y, and so x is the same data as the previous in the previous example. So now we need to calculate x square. X square already calculate, xy also already calculate from the previous example. So we need to have additional column for x minus x bar, y minus y bar, x minus x bar square, y minus y bar square, and also the multiplication of x minus y bar, x minus x bar multiplied by y minus y bar. So first, we need to calculate the average value of y data and also the average value of x data that represented by y bar and also x bar. Okay. Okay, now we need to calculate the y minus y bar. What x minus x bar, y minus y bar. So we need to calculate. And then we need to calculate the x minus x bar square and summation all the data that obtained. Y minus y bar square, and also we need to sum all the data for x minus y bar, y minus y bar square. And also we need to calculate x minus x bar multiplied by y minus y bar and make summation of all of the data as shown in the figures, as shown in the table. And we need to substitute all the data involved in the equation based on the equation for the Pearson correlation coefficient. So based on the Pearson correlation coefficient, R value that we obtain from the equation will be 0.9694. So which is the value considered close to the 100% or 1.0. So in terms of interpretation based on the value, the relationship is positive with strong linear relationship, which is significant variable. If we calculate R squared value also will have high value of R squared, which is equal to 0.9397. So in terms of interpretation, the model has good ability to explain to explain the variation in the dependence variable. So these are the example how we want to determine the correlation coefficient in terms of R. If you want to show whether the line is strong linear and how good the linear equation explain the variation of the dependence variable for the energy consumption data and so on. If the data or the result that we obtain is not significant, what should we do? Okay. So if correlation is not significant, what should we do? So in order, as our indicator, so the minimum correlation coefficient based on this number of sample shown in the table, where if we have number of sample 10, so minimum correlation that acceptable will be 0.767. So the value of R that we need to obtain must be greater than 0.767. So number of sample, if the number of sample will increase, so the minimum correlation coefficient will be reduced as shown in the table. Most of the time, energy consumption is influenced by several variables. So in terms of equation, we'll have numbers. We have the value of energy consumption that represented by Y variable will affected by numbers of x data as shown in the equation. We have m1 x1 plus m2 x2 plus blah 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 plus mn xn plus c. So we have not only one variable involved affect the y variable. So x1, x2 until xn refer to the variable that influence the y. Y for this case refer to the energy consumption. So if you want to consider interval of calculation by using hand calculation, it is difficult to solve multivariable analysis by using this method. We need to have specialized computer software, which is referred as the advisable method that can be used to determine the statistical relationship between the variables. If the model is not statistically valid and reliable, relevant variable may be missing. The reason may be, there are a few reasons. So the reason, maybe the relevant variable may be missing. So we need to eliminating data outliers. So we need to change data aggregation period, for example, hourly versus daily or versus monthly. Typically, the model for energy consumption will be developed using values of the relevant variable during the baseline period. So normally, in order to create the model, we need to use data for the during the baseline period measurement. Okay, so we already discussed this. I call this graph, where normally the model, which is in order to develop the model, we need to refer to the data in the baseline period. Okay. So the data, the baseline data we'll use for model development, for example, to obtain the equation for y equal to mx plus c and so on. So the data actually, for example, the example in order to determine the value of y, mx plus c in previous example, actually the data must be come from the data that we measured within the baseline period. Still under linear regression analysis, we will have another type of analysis which is refer to the cumulative summation, CUSUM. So CUSUM actually stand for cumulative summation deviation method. Consider a measure of the progressive deviation from a standard consumption pattern. Cumulative sum, CUSUM, represent the difference between the baseline, expected or standard consumption, and the actual consumption point over the baseline period of time. So the CUSUM provide a trend line, calculate saving and also losses to date, and shows when the performance change. Step in order to develop I call CUSUM. First, we need to plot a scatter graph of the two variables under consideration for the baseline period and derive a standard performance against times. Next, use the standard performance equation, for example, the linear regression equation, to calculate the predicted energy consumption for each month. Next, for each data point, subtract the predicted consumption from the actual consumption. For each data point, obtain the cumulative total deviation from predicted consumption. This gives the CUSUM value for each data point. And the last one, plot the CUSUM value versus time. For example, this example of the CUSUM. Okay, so the orange color line represent the predicted or standard, which is data come from the baseline data, and the predicted line or data actually come from the standard performance equation that we develop by using, for example, the linear regression analysis. The blue color line represent the actual data that we measured throughout the years within the reporting period, and the gray color line represent the CUSUM line. Okay, and the CUSUM graph or line shows the trend line, and we can know which month we will have saving in terms of energy consumption, and also we will know which month we will have loss in terms of energy consumption. And also we can see the performance change throughout the year if we have the reduction in terms of CUSUM data. Okay, example how we want to develop the CUSUM graph. We will use the same data. So now we need to add a few columns by using the same data, y data and also x data from the previous example. Predicted data, which is represented by y star. So y star actually the data will come from the equation that we developed by using the linear regression in the previous example. Okay, so if you want to get the predicted y star data for individual month, so we need to substitute the value of x and also y for individual specific month into the equation. So, and then we need to have a second additional column, which is represent y star minus y individual y data. And then we can develop the Kusum data, where for the first data of Kusum, we will equal the first data of y star minus y. And then for the second data, we need to add the first data of Kusum with the second data of y star minus y. So we will get the second data for the Kusum. The second data of the Kusum, we need to plus with the third data of y star minus y, and we will get the third data for the Kusum, and so on. So this is how we develop data for the Kusum. So we can plot the data for the energy consumption versus month or versus time. Okay, so we will get the predicted line or graph, which is represent the y star value. We will get the actual y data, and also we will get the Kusum data. So the purple dot represent the saving. When the graph or the data reduce compared to the previous data, so we can see the losses in terms of energy consumption, which means we will use more energy compared to the predicted data. Okay, so the data we consider as saving in terms of energy consumption if the data less than predicted value, and we consider loss in terms of energy consumption if the data greater than the predicted data. So if we identify the losses, so we need to, the losses in terms of data, losses in terms of energy consumption where the data is far higher than the predicted one. So we need to conduct investigation and take action for the improvement, so that for the next time, so we can reduce the losses throughout the years. Okay, now identifying static factor. Static factors are parameters that do not regularly change over time but can significantly influence energy performance. Why do we need to identify static factors? First, to ensure accurate comparison, where static factors provide context to ENPI and also ENBS, ensuring fair and meaningful comparison over time. So the data will support normalization. They help normalize energy data to isolate performance changes from variation caused by this factor. Improve energy analysis. Accounting for static factors enable better identification of true energy efficiency improvement. For example, in terms of facility characteristic, size, square foot of a building or production area, layout, the arrangement of equipments, workplace, infrastructure, installation level, and the type of building material. So these are the example of static factor based on the facilities. Based on the equipment design, so we have specification. So these are fixed factor such as power rating, kilowatt, efficiency level, operational capacity. Fixed operating conditions such as maximum temperature or pressure for the boiler. Under operational factor, static factor for the operational, such as number of shifts, fixed number of working shifts in a day, fixed schedule, regular operating hours, and under regulatory or organizational standard, so we have compliance requirement such as standard or code detecting specific energy use, and also the business policies, standards or codes detecting specific energy use. So these are examples of the static factors. Okay, now about the data collection and quality assurance. So this step actually critical for ensuring the accuracy and reliability of energy performance analysis. High quality data form the foundation for effective energy management by providing a clear understanding of energy use, identifying inefficiencies, and enabling informed decision making. So key objective for this data collection and also the quality assurance. So accurate energy performance analysis to ensure data accuracy, to ensure data accurately represent energy consumption and also influencing variable, to support energy baselines and energy performance indicator. So the data will provide reliable data to establish baseline and track performance improvement, enable consistency, maintaining uniformity in data collection method for fair comparison over times, and the last one, facilitate compliance, meet the documentation requirement of ISO 50001 or other regulatory frameworks. So these are key objectives of the data collection and also quality assurance. In terms of step for the data collection and also quality assurance, so first we need to define data requirement. So what kind of data we need to collect? So we need to collect the data in terms of energy consumption data, static factors, and how often to collect data can be real-time for dynamic system, weekly or monthly for utility billing data. Next, establish a data source. So we have primary source such as utility bills, metering system. Primary source we can obtain from the utility bills, metering system, building management system. Secondary source we can such as the environmental variables, such as secondary source such as environmental variable. Step number 3, use appropriate tools and method. We can use measurement tools such as permanent meter for continuous monitoring, portable device for periodic measurement, and also we can use data logging, data logger for detailed monitoring over time. Step number 4, ensure data quality such as accuracy, validate data against known benchmark or specification. Example, cross-check meter reading with utility bills. Completeness, ensure no gap in data by monitoring for misreading or system downtime. Consistency, use standardized unit and measurement method for comparability. Example, use kilowatt hours consistently for electricity data across all equipment. Relevance, collect data only for variables and system relevance to energy performance. Timeliness, ensure data is collected and recorded promptly. Step number 5, implement a quality assurance processes, regular calibration, calibrate meter and sensor periodically to maintain accuracy. For example, verify the accuracy of a flow meter every 6 months, error check, analyze data for outliers, or analyze that may indicate errors. Example, sudden spike in energy use that are not explained by operations. Documentation, we need to maintain record of data sources, collection methods, and quality assurance checks. So these are the steps we need to conduct for the data collection and quality assurance. Okay, now we focus specific to the energy performance indicator. Energy performance indicator, or ENPI, is essential for evaluating, monitoring, and demonstrating improvement in energy performance. So what is ENPI? ENPI actually the measure or energy performance indicator is the measure that quantifies result related to energy efficiency use and consumption in facilities, system, processes, and equipment. ENPI criteria: first, suitability. ENPI must align with specific operation and also objective. If improvement tracking, ENPI should demonstrate measurable energy performance improvement. Variable consideration, so relevant variables affecting energy performance must be accounted for. Method documentation, the process for ENPI determination must be documented And the last one, baseline comparison. ENPI value should be compared against energy baseline. Step to determine or use ENPIs. First, identify energy use and objective. Analyze significant energy use and set objective. Number 2, select relevance matrix. Choose indicator that align with energy objective. Number 3, consider relevant variables. So we need to identify factor influencing the energy use. Number 4, establish energy baseline. Set a baseline for comparing energy performance indicator values. Number 5, monitor and compare ENPI values. So we need to track ENPI values and compare to the baseline. And the last one, we need to update and review ENPI. Periodically review and also update ENPI. So these are the steps to determine and use the energy performance indicators. Okay, now type of energy performance indicator. ENPI based on measured energy value. ENPI based on ratio of measured value. ENPI based on statistical model. And the last one, ENPI based on engineering model. So under the type of measured energy value, so ENPI types measured energy value refer to the expression of the energy efficiency, useful for measuring reduction in absolute use or consumption of energy, meeting regulatory requirement based on absolute saving, monitor and control of energy stack and costs, understanding trend in energy consumption, and useful for obtain when measurement of energy consumption is given by a meter with or without a conversion factors. Example in terms of ENPI, such as the energy consumption kilowatt hours for lighting, fuel consumption gigajoule for the boiler, fuel consumption gigajoule of boiler, electricity consumption kilowatt hours during peak hours, peak demand kilowatt in months, total energy saving gigajoule from energy efficiency related program. In terms of observation, does not take into account the effect of relevant variables, giving misleading result for most applications, does not measure energy efficiency, does not measure energy efficiency. So these are the criteria for the ENPI based on measured energy value. Okay, ENPI based on ratio of measured value. So ENPI types, ratio of measured value, which is referred to the consumption of an entire site or one or more energy users measured by a meter. Useful for monitoring energy efficiency of system that have only one relevant variable. Monitoring system where there is little or no base load. Useful for standardizing comparison across multiple facilities or organization for the benchmarking. Useful for understanding energy efficiency trend. And the last one, useful for can be used, the ratio can express the energy efficiency of a piece of equipment or a system. Example, kilowatt hours per ton of production, gigajoule per unit of product, kilowatt hours per meter cubic of floor space, gigajoule per man day, liters of fuel per passenger kilometer, conversion efficiency of a boiler in terms of percent, input energy per output energy, kilowatt hours per megajoule for cooling system, kilowatt per meter cubic for compressed air system, and the last one, kilowatt hours per unit of sales. So these are example of ENPI under ratio of measured value. Observation does not account for base load and non-linear energy use effect, will be misleading for facility with a large base load. Okay, ENPI based on statistical model. So statistical model refer to the relationship between energy consumption and relevant variable using linear or non-linear regression. Useful for system with several relevant variables, system with base load energy consumption, where comparison requires normalization. Useful for modeling complex system where the relationship between energy performance and the relevant variable can be quantified. And useful for organization level energy performance with several relevance variables. And also useful for illustrate the relationship between energy consumption and also relevant variables. So example, energy performance of a production facility with 2 or more product types, energy performance of a facility having a base load, energy performance of a hotel with variable occupancy rate and also outside temperature, and also the relationship between the energy consumption of a pump or fan and the flow rate. Observation for model with multiple variable relationship can be difficult to determine, and model can take time to create and can be difficult to ensure accuracy. May not clear if any residual error is due to modeling error or lack of control over energy consumption, and may be inaccurate if not confirmed by statistical tests, and require a detailed system of understanding to define the correct functional form of relationship expected when data are not linear. And model should be maintained to ensure valid result. Okay, the last one based on engineering model. So ENPI type based on engineering model actually refer to the relationship between energy consumption and relevant variable using engineering simulation. And this ENPI based on an engineering model is useful for evaluating energy performance from operational changes where variables are numerous, transient processes, and or system involving dynamic feedback loops. And also useful for system with interdependent relevant variables such as temperature and also the pressure. And the ENPI also can be used for estimating energy performance at the design stage. For example, industrial or power generation system where engineering calculation automation enable accounting for changes in relevant variables and also their interaction. Model of the electricity consumption of a chiller using the demand for cooling, the outside temperature, which is referred to the condensing temperature, and also inside temperature, which is referred to the evaporating temperature. Whole building model that account for hours of operation, centralized versus distributed HVAC system, and varying tenant needs. Observation model should be maintained to ensure valid result. Observation model should be maintained to ensure valid results. So these are according criteria for the ENPI based on engineering model. Okay, now example of energy performance indicator based on the manufacturing industry. For example, ENPI kilowatt hour per unit produced, baseline 50 kilowatt hours ton in 2022. So baseline normally refer to the previous year data. Performance improvement goal reduced to 45 kilowatt hour per ton by 2024. For the office building, the ENPI will be energy use per square meter, kilowatt hours per meter square, or kilowatt hours per occupant hours. Baseline 120 kilowatt hours per meter cubic in 2023. Performance improvement goals reduced to 100 kilowatt hours per meter cubic by 2025. Data center ENPI, power usage effectiveness PEU, equal to total facility energy divided by IT equipment energy, baseline 1.8 in 2021, performance improvement goal, achieve PUE of 1.6 by 2022. Fleet operation ENPI, fuel consumption per kilometer, liters per kilometer, baseline 5 liter per kilometer in 2022, performance improvement goal reduced to 4.5 liter per kilometer by 2024. So these are the example in terms of ENPI, baseline, and also the performance improvement goals. So at least we can differentiate between ENPI, baseline, and also the goals for each individual sector. Okay, now example and also application of energy performance indicator ENPI. So the table shows what I call the example of the energy performance indicator in terms of application. So we have here we have a column for item in terms of company types, process, intention, improvement action, ENPI, and also ENB, targets, and so notes. So the next column refer to the example number 1 until example number 4 based on different type of ENPI. For the first column, the example and also application for the ENPI based on measured energy value, followed by ratio of measured value, statistical model, and also engineering based model. Okay, so you can read by yourself. No need to explain. So the table clearly state what I call the company type, processes, intention, improvement, action, ENPI, and also ENB. Also the target for each example. Okay, energy baseline. So energy baseline actually essential for tracking energy performance over time and enable to access changes in energy performance between selected periods. And consider a reference that characterizes and quantifies energy performance during a specific period. And this parameter used to calculate energy saving and as a reference before and after implementing energy performance improvement action. And also used to determine the ENPI value for the baseline period. So the purpose of energy baseline as the reference for comparison, provide a benchmark to measure energy performance improvement, progress evaluation, track progress toward achieving energy objective and target, demonstration of improvement, serve as documented evidence of energy performance improvement for audit and also stakeholders. Step for the energy baseline. So we need to determine the specific purpose, monitor the impact of energy saving initiative. Next, determine a suitable data period, reflect normal operation condition. The duration should be long enough to capture variable, irrelevant variable. For example, the production and also weather. Avoid period with irregular operation. And then data collection, gather energy consumption data and relevant variable for the baseline period. And the last one, determine and test the energy baseline. Method to determine: simple, average, regression analysis, normalization, test the ENB, energy baseline, validate the energy baseline by comparing it to actual performance data during similar operation condition. When models are used, the validity of the energy baseline can be determined using statistical tests such as the p-value, f-test, or the coefficient of determination to determine its. When models are used, the validity of the energy baseline can be determined using statistical tests such as p-value, f-test, or the coefficient of determination to determine if the statistical model has been best fit from the data. So these are the steps to determine the energy baseline. So example for the energy baseline, based on the facilities, wide baseline purpose, measure total facility energy efficiency, ENPI, energy used per square meter, kilowatt hours per meter squared, baseline period, 12 months of energy consumption data, and test, compare baseline energy intensity with historical data for similar occupancy level. Equipment specific baseline, purpose, track boiler system performance, for example. These are the example. ENPI, energy consumption per ton of steam, kilowatt hours per ton, baseline period, 3 months of normal operation. And tests need to be conducted, validate against historical efficiency data for similar steam demand. So these are the example of the base. So they are the example of energy baseline for the facility and also for the equipment. Okay, next about the using ENPI and also ENB. Okay. So we need to determine the ENPI and also ENB when normalization is needed. So in case of a single significant relevant variable and a small base load, a simple ratio of energy consumption divided by the relevant variable can be used. In case of multiple relevant variables or a large base load, a model describing the relationship between the energy consumption and relevant variable is used. If the model is not statistically sound, then it may need to be explored. In terms of relevant variable may be missing, we need to eliminating data outliers and change data aggregation period. Typically, the model for energy consumption would be developed using value of the relevant variable during the baseline period. For calculating energy performance improvement, quantify ENPI during the reporting periods and compare this value to the corresponding energy baseline. The organization also should compare the quantified energy performance to its energy target and take action. Communicating changes in energy performance. So presenting energy performance involves effectively communicating the key metrics and comparison needed by the stakeholders to assess progress toward energy objective. The presentation typically includes ENPIs and ENB and energy target values tailored to the audience needs. Maintaining and adjusting ENPI and also ENBS, ensuring they remain accurate and relevant and effective in reflecting energy performance, especially when significant changes occur in the facility, system, or processes. Adjustment here means the process of modifying the energy baseline in order to enable energy performance comparison under equivalence condition between the reporting periods and also the baseline period. Why we need to adjust the ENPI and also ENB? So this is due to the change in operation. For example, the modification to the processes, production level, or equipment. So we want to reflect the new realities where we need to update the indicator and also baseline will be ensure meaningful data, avoid misinterpretation. So we need to prevent false conclusion about energy efficiency improvement due to the changes in variable. So that's why we need to adjust regularly the value of ENPI and also ENBS. Okay, what is the normalization? So normalization actually is process of routinely modify energy data in order to account for changes in relevant variable to compare energy performance under equivalent conditions. So the ENPI quantifies the mathematical relationship between energy consumption and also the relevant variables. So normally we will use the linear regression. Okay. For example, so the equation actually same as the equation that we have learned before for the linear regression where y equal to ma. For this case, the linear regression that we obtain for energy consumption EC, unit kilowatt hours, equal to A plus B multiplied by product A plus C times T. So A represent the fixed energy consumption base load, which is in kilowatt hours. B stand for energy consumption per unit of product A, kilowatt hours per unit. Product A refer to the product volume of product A. C refer to energy consumption per degree of monthly temperature per weeks, kilowatt hours per degree Celsius. And T refer to the average monthly temperature. Factor A, B, C actually derived from the statistical modeling method used to develop the linear regression. This relationship should meet statistical tests such as coefficient of discrimination R square. So this example from the previous graph, which is referred to the energy consumption versus time. So we have the data for the baseline period, the data for the reporting period, and in between we have installation period. So the blue color line represent the energy consumption base, which is referred to the energy consumption that measure during the baseline period. We have EC rep actual, which is referred to the energy consumption representative for the actual data. We have the dotted line for the EC rep estimate, which is referred to the energy consumption representative for the estimated data, and delta EC, the difference between estimated data and also the actual data. So REP represent the representative, EST represent the estimated, ECT represent the actual data. So for each data actually consists of two variables, at least energy consumption versus relevant variable data. For this case, we refer as the production. So the pink color line represent the what I call the production data within the baseline period and also within the reporting period. So the data for production within the baseline period refer to the P base, and within this reporting period refer to the P representative. So from the linear regression, the equation that we obtain, EC equal to A plus B multiplied by product A plus CET, we can estimate energy consumption, where EC representative for the estimated equal to function of P rep. Also, we can know the energy consumption changes that represented by delta EC, where delta EC equal to EC representative, delta EC equal to EC representative estimated minus EC representative for the actual data. Okay, so the model of EC equal to F function the development of the model, which is EC equal to function of P, actually come from the data, the analysis of the linear regression from the data that we obtain from the baseline period. Okay, so from the model we can predict for the reporting period, we can predict based on the value of production P representative. We substitute into the model, so we can estimate the value of energy consumption EC representative for the estimated data as shown in the figures. So this is how we use the model in order to estimate the energy consumption data for during the reporting period. Okay, so in terms of presentation or visualization, okay, in terms of presentation, also visualization, in terms of energy indicator, energy performance indicator, and also energy baseline value. So these are numbers of graph that can be used, or numbers of schematic diagram that can be in order to present the value of ENPI and also ENB. For example, this is the chart that provide the overview of monitoring and also reporting energy performance. And this chart or schematic diagram shows the ENPIs regarding energy efficiency and also energy use. And also we have the graph that shows the relationship between energy performance indicator and also the target. So these are called the visualization tools that can be used to explain or convey the information about the energy consumption based on ENPI and also ENB. Okay, so these are another form of presentation or visualization. So this graph shows the specific energy consumption chart, and the second one shows the energy consumption versus production chart. So we can choose any kind of visualization which is suitable to the certain organization. The important thing is we can convey in terms of the information in terms of energy consumption, and for the improvement, and also for the action that we need to conduct to reduce the energy consumption for the specific organization. And now step 2, maintain and adjust energy ENPI and also ENBS. First, step number 1, test the validity of existing ENPI and also ENB. Comparison of relevant variables, and also involving static factor analysis. Step number 2, determine the needs of adjustment. Number 3, method for adjusting ENBS, such as statistical model for backcasting, standard condition approach, or we can use the combination of methods. Step number 5, document adjustment. And now we have the overview of energy performance improvement. So we have we have obtaining relevant energy performance information from the energy review, and then we need to identify the ENPIS. We need to establish the ENB. After that, using ENPI and also ENBS, and then maintaining and adjusting ENPS, and then maintaining and adjusting ENPIS, and also ENBS. And then we need to have continuous improvement, and we need to repeat the processes. So these are the overview of the energy performance. Okay, the last section for this topic for chapter number 5, part number 2 is about the planning for the collection of energy data. Okay, so for this step, we want to ensure the organization systematically gather, monitors, and analyze energy-related data to improve performance. So this structured approach enables tracking key operational characteristics, support decision-making, and demonstrate compliance with standards such as ISO 50001. Key components: identification of key characteristics such as energy consumption, relevant variable, static factors, operational criteria, and the next key component is data categories to collect. So we need to collect relevant variable for SEUS, energy consumption related to SEUS, operational criteria related to SEUS, and also the static factor. So we need to collect also the data from the action plan. Next key component is the measurement and also monitoring equipment in terms of accuracy, calibration, repeatability, and then data collection detail, how data is collected. We need to know how data is collected. We need to know the frequency of data collection, retention period, and the last one, the documentation and review. So we need to plan the documentation process, measurement method. Okay, so we need to document and review the plan documentation, measurement method, data record, equipment calibration, and also the plan review. Okay, now step to develop an energy data collection. So first, we need to define the scope, determine the scope of the data collection plan, align objective with organizational energy goal and target. Number 2, identify characteristic, identify SEUS and relevant variable, document static factor and operational criteria. Number 3, select methods, choose appropriate instrument and methods for accurate data collection. Number 4, develop schedule, define the frequency for the data collection and also monitoring. Number 5, ensure accuracy, use certified measurement tools, implement a calibration and maintenance schedule. Number 6, document plan, data types and sources, collection method and frequency, responsibility for data collection and maintenance. Number 7, implement and review. Roll out the plan across the organization. Periodically review and update based on changes to SEUS processes or objective. Okay, so these are the key components and also steps involved for the data collection plan. Okay, example for data planning for data collection. So we have data types such as energy consumption for SEUS, production output, HVAC system energy use, ambient temperature, static factor, Based on facilities, LED lighting, retrofit saving. So we have source column, frequency, method, and also retention. For example, data type in terms of energy consumption for SEUs, the source will be come from the submeters, frequency will be real times, method, automated monitoring system, retention, probably we will measure for 3 years. Okay, the second one for the production output, source come from the production log, frequency daily, method manual entry, retention 2 years, and so on. So you can read by yourself. I call the example of the planning for the data collection. Okay, so that's all for chapter number 5, part number 2. Assalamualaikum.